Today we are talking about a magical formula called the quadratic formula. You have heard about it before, not just in class, but probably elsewhere. And it is this formula that we use to solve a polynomial equation that has x squared, x, and a number, right? So it's a quadratic equation, meaning that we have that x squared term. Okay, so the equation is when I start with ax squared plus bx plus c is equal to 0, right? These coefficients, I'm going to plug into this equation, which is x is equal to negative b plus or minus the square root of 4b squared minus 4ac all over 2a. So if I have something like 2x squared minus 8x plus 7 equals 0, that means a is equal to 2, b is equal to negative 8, and c is equal to 7. So I'm just going to plug all of these into that magical formula. So negative 8 plus or minus the square root of negative 8 squared minus 4 times a, which is 2, times c, which is 7, and that's all over 2a, which is 2 times 2. So I end up getting 8 plus or minus the square root of 64 minus 4 times 2 times 7, which is 56, and that's all going to be over 2 times 2, which is 4. So then I end up with 8 plus or minus the square root of 8, and that's over 4, and then 8 plus or minus 2 root 2 over 4, or 4 plus or minus root 2, and that's all over 2 once you cancel that. Okay, so that's just, basic algebra of solving numbers and simplifying until we get to that final answer. But basically we have this equation, which seems like magic. We can solve any equation, right? But it's not really magic. We can actually derive this formula from what we've learned before. We have learned to complete the square, yes? So we know how to solve a quadratic if we just sort of complete the square and then factor and then, take the square root of both sides. Okay, remember that we were getting things in the form of x squared plus 2 alpha x plus alpha squared, right, with nothing in front of that x squared term. So I'm going to start by subtracting c from both sides of this original equation, and then by dividing by a so I can get rid of the coefficient in front of my x squared. So then I would have x squared plus b over ax is equal to negative c over a. Okay, so now I can do my 2 alpha business. 2 alpha in this case is just equal to b over a, which is the thing in front of the x. And then if I multiply both sides by 1/2, I end up with alpha is equal to b over 2a. Which means that alpha squared is just b squared over 2 squared a squared, which is b squared over 4a squared. Okay, so that means I'm going to add b squared over 4a squared to both sides of my equation. Now, on the left-hand side, I know that this always factors into x plus alpha squared, okay? Which is really helpful in this case because alpha is equal to b over 2a. So this is going to factor into x plus b over 2a squared. And that's going to be equal to the other side of the equation. Now I'm going to make c over a have the same base as the other one, 4a squared. So I'm going to multiply it by 4a so that both bases will be 4a. And then I end up with negative 4ac plus b squared over 4a squared. Okay, then I can take the square root of both sides. I'm going to switch b squared and 4ac. You'll see in a second why. And then on the bottom there, the square root of 4a squared is just 2a, so I can take that out. So I end up with x is equal to, once I subtract negative b, or subtract b over 2a, I end up with x is equal to negative b over 2a plus or minus the square root of b squared minus 4ac over 2a, and then those are the same base, right? Which means that I can combine the tops. And what you see is the magical formula that I just told you about. There it is, the quadratic. So we solved this by completing the square. We found the quadratic formula by completing the square. So really all you need to be able to solve quadratic equations is to use completing the square. You don't have to use a quadratic, but it might be helpful because it's kind of a nice formula. It's all neat and tidy. However, you will have to know how to complete the square. We will do that later when we're graphing polynomials and circles and all of that. So you have to know it. But here, this is kind of nice to use a quadratic for now. So suppose I have this equation, 2x squared minus 3x equals 7. The first thing I would do is actually move the 7 back, because we're not completing the square, we're trying to use the quadratic equation, so that I can have a is equal to 2, b is equal to negative 3, and c is equal to negative 7. Okay? We're going to watch carefully those negative numbers. So first, x is equal to negative b, which is negative 3, plus or minus b squared, which is negative 3 squared, minus 4 times 2 times negative 7, all over 2a, which is 2 times 2. So I end up with 3 plus or minus 9 minus 4 times 2 times negative 7, right? So 4 times 2 is 8, 8 times 7 is 56, and because there's two negatives there, negative 4 and negative 7, that's going to end up being not minus 56, but actually plus 56, okay? So we're going to have 3 plus or minus the square root of 9 plus 56, and that's all going to be over 4. Okay, so just watch those negatives, yeah? 9 plus 56 is 65, and that's going to be over 4. 65 factors into 5 and 13, so we can't reduce that at all, and this is my final answer. We are going to do another example involving the quadratic formula. Suppose that we have 2w squared plus 4w is equal to negative 3. Okay, first things first, I want to get the 3 on the left-hand side of the equation, so I just have everything on one side, the other side equal to 0, because then I can use my quadratic formula. And in this case, a is equal to 2, b is equal to 4, c is equal to 3. So then I say, okay, w is equal to negative b, which is negative 4, plus or minus b squared, which is 16, plus, not plus or minus again, minus 4 times 2 times 3, all over 2a, which is just 2 times 2. So negative 4 plus or minus 16 minus 4 times 2 is 8, so that's going to be 8 times 3, which is 24. And then that gives me a negative 8 once I subtract 16 minus 24. Now negative 8 has an I in there, right? And the square root of 8 is just 2 root 2, because 8 when factored has 3 2's in it, if you'll see here in a second. So 8 is 2 and 4, and then 2 and 2. There's a pair of 2's and a 2 left over, so it becomes 2 root 2. Okay, we're good almost, except that we need to reduce this. So then I end up with negative 2 plus or minus I root 2, and that's all over 2. And because I have an I need to split up the 2 over each. So 2 divided by 2 is just 1. So it'll be 1 plus or minus I root 2 over 2. Or there's another way of writing it, 1 plus or minus root 2 over 2i. Okay, that would be kind of a neater way of writing it. I feel like they changed the rules a lot of whether you write the square root first or whether you write the I first. Anyway, if you do it in a way that the solution didn't say, I'm not going to think it's a huge deal, but just make sure that you do separate the I term. That is important. Okay, suppose we have a rectangle that's 5 by 6, and we extend each of the sides so by x, right? So they're each x bigger. Now the original area is of course 30, because 5 times 6 is 30. And they're going to tell us that the new area is going to be 3 times the old area, which means it's going to be 90 centimeters squared. Okay, so the area of the new shape is just x plus 6 times x plus 5, because those are the lengths of the sides, right? And that should be equal to 90. So then when we expand that, it's x squared plus 11x, that's 6x plus 5x, plus 30 is equal to 90. I subtract 90 from both sides, and I end up with x squared plus 11x minus 60. Now, in this case, a is equal to 1, b is equal to 11, c is equal to negative 60. I'm going to plug this all into the quadratic formula, so I end up with negative b, which is negative 11, plus or minus 11 squared, or the square root of 11 squared, 121, minus 4 times 1 times negative 60, and this is all over 2 times 1. 4 times 60 is 240, right? And they're both negative, so I end up with a plus 240. And if I finish solving, I end up with 361 inside that square root. If I just take out my calculator real quick, the square root of 361 is just 19. I haven't had that one memorized. If you do, that's really cool. I wish I had that memorized. Anyway, we get negative 11 plus or minus 19 over 2. So negative 11 plus 19 is 8. 8 over 2 is 4. Negative 11 minus 19 is negative 30. Over 2 is negative 15. But I'm not going to take that solution because remember, we're talking about a shape. And a shape cannot have a negative solution. It can only have a positive solution, right? That side cannot be negative 15. That wouldn't make any sense. So 4 centimeters is the correct answer. So a lot of times with these problems, you're going to find that, oh wait, I'm not actually going to include all of my solutions here. I'm only going to include the one that's positive because that's the only one that makes sense in the context of the problem. Okay, so I need to find the area of this trapezoid. I have x, 2x, x plus 6. The area of the trapezoid, actually, they tell me, is 90. Okay, but I need to figure out what x is. So first I'm going to divide this shape up into a triangle and a rectangle. And the total area will just be the area of the rectangle plus the area of the triangle. Now the area of the triangle is just x times x plus 6, which is x squared plus 6x. And the area of the triangle is just 1/2 of that base, which is x plus 6, times the height, which is x. So I get 1/2 times x plus 6, which is equal to 1/2 x squared plus 3x. Okay, now if I add those two areas, again, it's going to equal the total area, which is equal to 90, which means 90 is equal to 1x squared plus 1/2 x squared, which is 3/2 x squared, plus 6x plus 3x, which is 9x. So then I kind of rearrange this, so I have all my terms on one side, the other side is equal to 0, and then I'm just going to multiply everything by 2 because I just don't want to deal with that fraction. So I'm going to multiply all my things by 2, so I end up with 3x squared plus 18x minus 180 equals 0, where a is 3, b is 18, c is negative 180. Perfect. Okay, so we're going to plug this into the quadratic formula. Woohoo! That woohoo is just to keep you interested in this video. So maybe if you were starting to zone out, there's a little woohoo. Anyway, we're just plugging it into the quadratic formula. I'm not going to mutter on about how this works. You can try it on your own. This one might be helpful to use your calculator, right, to multiply all those things out. But you will get so much practice using the quadratic formula that you'll probably be good to go to do this all on your own. So once I figure this out, the whole thing, right, and I take the square root, I end up with negative 18 plus like 49.8 over 6. Now, I'm not going to do negative 18 minus 49.8 because I can already see that's going to be a negative number, and I was talking about a shape, right? What is x as part of this shape? And it can't be a minus. It can't be a negative. So I'm only going to take negative 18 plus 49.8 divided by 6, which ends up being 5.31. Good luck on your homework. Have fun using the quadratic formula.